Hello, prime factorization, everything you want to know about that. Prime factorization, I've got to do a commercial for that just a moment here. It's very useful, and you'll see as we go in the next coming sections how many different ways we can use it. So basically what prime factorization is, it's just the breaking down of a number into the product of primes, usually using something called a factor tree. It shows what a number's made up of. It's like tearing apart a watch to see what it's made of. For example, let's take the number 180. So we're going to tear that apart, see what it's made of. Does this look familiar, the factors tree? You can start anywhere with this, anything that multiplies to give you 180. So let's just start with 10 and 18. Neither of those are prime, so that means those can be broken down further. 10 is 2 times 5. Woohoo! We've got a prime and we've got a prime, so we know that those are finished. There's nothing more to do there. For 18, let's try 2 times 9. There's another prime, and 9 is 3 and 3, so we are finished. So we can say at this point that 180, what it's made up of, let's put it in order. We've got 2 2s, 2 3s, and then that little lonely 5 over there. And if you want to use your exponents, we can do 2 squared times 3 squared times 5. That's pretty much it. One thing I will point out, though, the two most common uses of prime, and I'm just going to start calling that PF, prime factorization. The first one, finding the greatest common factor, and I'm not going to write any more about that because that will be coming later. And what we're going to be using the prime factorization for now is finding the least common multiple. So let's write that down. Least common multiple. Okay, and you know what multiple means now. It's the numbers that a number goes into. Least, we want to find the smallest one that's common to 2 or more numbers. So I think we just got to go to another example here. So let's try, let's see, how about 52? Start anywhere. So one thing you can do is that number divisible by 2? Yeah. So we know that 2 goes into it, and then you may have to divide it out to see what you get, and you would get 26. That one's finished. 26 can be torn apart further. 2 times 13. All of those are prime, so we say, okay, 52 is equal to 2 times 13, or 2 squared times 13. Okay, I have another one. Let's try 231. So we're finding the prime factorization of 231. So what goes into 231? Does 2? No. Does 3? Remember how we decide if 3 goes into a number? We add up those digits. 2 plus 3 plus 1 gives us 6. So we know that 3 goes into it. So we can say, okay, 3 goes into it, and we may have to divide that out. That would give us 77. 3's prime, so we know that's finished. 77, 7 times 11. There we go. We are there. 231, then, when it's all torn apart, it is made up of 3 times 7 times 11. Let's try, how about a bigger number? 300. Let me make that a little bit prettier. 300, where do you want to start? Well, I feel like starting, whatever. Let's start 2 times 150, finished. 50, it doesn't matter what you find. Anything that multiplies to give you 150. So I'm going to say 3 times 50. There's another prime. 50, 2 times 25. 25 is 5 times 5. So we're there. So we can say then that the prime factorization of 300 is 2. Let's get both of them there. Times 2 times 3. And then we've got these two 5s times 5 times 5. Okay, the last one I'm going to show you is 289. Now, if you start this, you say, well, is it divisible by 2? No. Is it divisible by 3? Well, if we add up the digits, we get 19, and that's not divisible by 3, so it's not divisible by 3. If it's not divisible by 4, it's not going to be divisible by any even number. So we've tried 2, 3, 4. What about 5? No. 6, well, that's an even. 7, well, we may have to try that. So over here on the side, we don't have a shortcut for divisibility for 7. 289, 428, 09. Nope, that's not going to go because it has a remainder. So if it has a remainder, we know it doesn't divide evenly. So you would need to try the numbers. Keep going. 289, da-da-da-da. Does 8? No. 9? No. 10? No. 11? No. And I'm just going to tell you, after you try all of those, you would get 17 does go into 289, and 17 times what? 17. So 289 in its prime factorization is 17 times 17, or 17 squared. Okay, I think that's good enough. So we will go to the next lesson, and that's making use of prime factorization to find the least common multiple.